The molding principle of 3D printing is an additive manufacturing technology. It is based on three-dimensional model data and creates objects by stacking materials layer by layer. For example, in the fused deposition modeling FDM process, a thermoplastic material is heated and melted, extruded from a nozzle, and deposited layer by layer according to a preset path until the entire object is completed. Selective laser sintering, SLS, on the other hand, uses a laser beam to sinter powdered materials together, also building the object layer by layer. Injection molding is a material reduction manufacturing technique. After heating thermoplastic or thermosetting plastic to a molten state, it is injected into a pre-designed mold cavity under high pressure, and the plastic is cooled and solidified in the mold, and the mold is opened to remove the molded product. The molding process mainly relies on the mold cavity to give the product shape. The productivity of 3D printing is an advantage for single-piece or small lot production. It does not require the production of complex molds, manufacturing directly from the digital model, and production lead time is short. However, the printing speed is relatively slow, especially for large, complex structural objects. The printing time may be very long. For example, printing a complex model of a mechanical part may take hours or even days, depending on the size and complexity of the part. Injection molding is extremely efficient when it comes to mass production. Once the mold is made, an injection molding machine can produce the same product in large quantities in a short period of time. For example, on a high-speed injection molding machine, it may take only a few seconds to mold a small plastic part, making it suitable for large-scale, highly efficient industrial production. The precision of 3D printed products is improving, but is still relatively low, especially in terms of surface quality. The surfaces of printed products may have laminations that require post-processing to improve the surface finish. However, 3D printing has advantages in manufacturing products with complex internal structures, enabling structures that are difficult to accomplish with traditional manufacturing methods. For example, lightweight parts with internal lattice structures can be printed to meet specific functional needs. Injection molding is capable of producing high-precision, high-quality products. Through precise mold design and manufacturing, the dimensional accuracy of injection molded products can be controlled at a high level, and the surface quality is good, usually achieving a smooth finish. However, injection molding may be limited in the manufacture of some products with complex internal structures because the difficulty of mold design and manufacture rises sharply as the complexity of the internal structure increases. The variety of 3D printing materials is relatively limited, although there are a variety of materials to choose from, such as thermoplastics, PLA, ABS, etc., metal powders, ceramic powders, photosensitive resins, etc. Each 3D printing technology has more stringent material requirements. For example, FDM technology mainly uses thermoplastic filament materials, and the performance and applicability of the materials will be somewhat limited. Injection molding has a wider range of material options. A variety of thermoplastics and thermosets can be used, and the properties of the material can be changed by adding additives, fillers, etc. There are more ways to adjust the physical and chemical properties of the material, such as strength, toughness, heat resistance, etc., to meet the performance requirements of different products. For single-piece or small lot production, the cost of 3D printing lies mainly in equipment depreciation, material costs, and labor costs. Since there is no need for mold making, the single-piece cost is lower for complex shapes or customized products. However, as the batch size increases, the unit cost of 3D printing decreases less. Injection molding has a higher upfront mold making cost. If the product batch size is small, the cost of the mold spread over each product will make the product more expensive. However, when the batch size is large enough, due to the high efficiency and lower material costs of injection molding, the unit product cost will be significantly lower and the economic benefits will be obvious.